Next, let's switch topics to talk about acids nomenclature. We will focus on those acids that have the hydrogen cation, and within this group, there is two types of acids. Those that do not contain oxygens, which are the ones shown here, and the ones that do contain oxygen, which are called the oxyacids, which we will talk about later. Okay, so let's write the names of these acids that do not contain oxygen. Okay, the first one is HF, so we need to first put the prefix hydro to indicate the hydrogen element. So we put hydro, and then we put the name of the root of the anion and the suffix ic, IC. Okay, so the root of the anion, in this case fluorine, is fluor. The suffix ic, so putting it all together, is hydrofluoric, and at the end we put acid. Alright, so this is hydrofluoric acid, is HF. Next we have H2S. So again we put the same prefix hydro, and the root of sulfur would be sulfur. The suffix ic, and putting it all together, is hydrosulfuric acid. The next one is actually an acid that has more than two types of atoms. So Cn is actually a polyatomic ion, cyanide. So this is something that follows the same rules. So hydrogen, we put hydro, and the root of cyanide is just cyan. And we put ic, suffix, and putting it all together is hydrocyanic acid. Okay. We can also write the formulas based on the names. The first one is hydrochloric acid. So hydro means that there is hydrogen. Chlor is the root of chlorine, and ic is the suffix, and then acid. So it should be HCl. The next one is hydrobromic acid. So this one is HBr, hydrobromic acid. The next one is hydroiodic acid. So this one is the root of iodine, hydroiodic acid. And lastly, let's check the charges of these acids. So hydrogen is a cation, so takes the charge of +1. So since there is a 1-to-1 ratio, chlorine has to be -1. And the same charge applies to all of these halogens. So hydrogen has a +1 charge, chlorine has a -1 charge. So does bromine and iodine. Next, we have the oxyacids. The oxyacids are acids formed by a bond between hydrogen and a polyatomic ion containing oxygen. And the way you write the names of these acids is the following. First, we start writing the name of the polyatomic ion, and then based on the suffix of the polyatomic ion, if it ends with "ate", we will end the acid name with "ic". If it ends with "ite", we will end the acid name with "-ose". Okay, so let's do some examples here. We have HNO2. So the oxygen ion formula is NO2 with a -1 charge. The name is nitrite. We see that it ends with "ite". So according to our rule, "ite", the acid name should end with "-ose". So this would become nitrous acid. Remember to always put acid at the end. The next one is HNO3, and the oxyanion formula is NO3 with a -1 charge. The name is nitrate. So this acid will take the suffix -ic, nitric acid. So we can see for ite, we change it to us, and for ate to ic. Okay, the next one is HC2H3O2. So the anion would be C2H3O2 and a -1 charge. The name of this is acetate. So because it ends with 8, we change the name of the acid with ic, acetic acid. Okay, then we have different types of chlorine with 4 different oxidation of states for chlorine. Okay, so the way we write these ones is the same way, but we need to be careful with the beginning, the prefix, and the suffix of the oxyanion name. So let me show you. So for the first one, we have ClO with a minus charge. This one, its name is hypochlorite. So we have the hypo prefix and the ite suffix. So in this case, we keep the prefix and we only change the suffix. So hypochlorous acid. The second one, ClO2 minus. And the name of this one is chloride. So it doesn't have any prefix. We only change the suffix to chlorous acid. The next one is ClO3 minus. This one is chlorate. So 8 changes to ic, chloric acid. And lastly, we have ClO4 minus, and this one is perchlorate. So we keep the prefix and we change the suffix. Perchloric acid. Let me mention a few things about the oxidation of states of these chlorine atoms. So if you do the calculation for each one of them, you will find that the oxidation state of the first one is +1, the second chlorine is +3, the third one is +5, and the fourth one is +7. For atoms that have 4 different states of oxidation, like chlorine or manganese, we use prefixes along with suffixes. So for the lowest oxidation of states, we use hypo, which means lowest, and then we use ite. For the second lower, we use ite. For the third oxidation of state, we use ate. And for the highest one, we use per, prefix, which means highest, and ate, the highest suffix. Lastly, we can write the formula of these oxyacids based on their names. To do that, we must follow these indications but backwards. As an example, we have sulfurous acid. So we look at the prefix OUS. That means that this acid contains a polyatomic ion that contains sulfur and has its lower oxidation of state. So that polyatomic ion is SO3 2-, and its name is sulfite. Remember that "ite" means the lower oxidation of state. So the formula of this would be H2SO3, sulfurous acid. The next one is sulfuric acid. So the prefix in this case is IC. So this one contains a polyatomic ion that contains sulfur and has a higher oxidation state. So this one is SO4 2- or sulfate. 8 means the higher oxidation state. So the formula for this is H2SO4 sulfuric acid. And the last one is carbonic acid. So we have again the prefix ic or IC. So this one has the carbonate polyanion. So carbonate. And the formula is H2CO3. Try these problems yourself. And here are the answers.